Hi everyone and welcome to MathSux. This video will help you pass the Algebra 2 Common Core Regents. So we're doing this one question at a time. Here is question 1. Which expression is equivalent to x plus 2 squared minus 5 times x plus 2 plus 6? So let's just write it on the side over here. And let's expand this guy out. And then we're just going to distribute everything. So x times x is x squared. So we'll put this together and we get x squared plus 4x plus 4. And now we want to bring this guy down and distribute that. Negative 5 to each term inside. So negative 5 times x is minus 5x. And then negative 5 times 2 is minus 10. And then we have this plus 6. So now we just need to combine like terms. So we have only one x squared, and then we have a 4x minus 5x, which gives us a minus x, and then we have these whole numbers, 4 plus 6 is 10, and then minus 10. So these whole numbers actually cancel each other out. So we're left with x squared minus x, and if you look back at the answer choices, there's nothing that totally looks like that, but if you look at choice 1, you can realize that they took out a GCF of x, and rewrite it this way. So the answer to number 1 is choice 1, x times x minus y. Question number 2. To the nearest tenth, the solution to the equation is. So we need to do some algebra and find the answer to this question here. So I'm just going to rewrite it on the side. And then just treating this like a normal algebraic equation. So we're going to add 123 to both sides. We could divide out this 4,300. So we'll want to use our calculator for this question. And we get this big long number here. We can rewrite this in order to solve this. Ln of this long number, 1.19139, and it keeps going, 5349, is equal to 0.07. Because remember, there's a little e here, e of 0.07x. There's a little e here, so when you think about converting this, you think e to the 0.07x is equal to, make like a little loop, so that's how you know you're right. So now we're trying to find the value of x, so we're just going to divide out 0.7 on both sides. 0.07 on both sides. So we're going to do this all on our calculator, ln, second answer, so ln of what we just got here is equal to this number, and then we're going to divide this number by 0.07, and we get x is equal to 2.5. which is choice number 2. Question 3. The value of an automobile t years after it was purchased is given by the function v equals 38,000 times 0.84 to the t. Which statement is true? So let me just write this equation down here. So notice that this growth factor value is between 0 and 1. So since it's between 0 and 1, we know that this is going to be a exponential decay. So it's exponential decay, we know the value of the car is going to be decreasing. So we can automatically eliminate choices 1 and 3. So decay. So if we actually look at the formula for an exponential decay, we get this number by taking 1 minus r, where r is the rate. So if we had 1 minus r is equal to 0.84, we have to figure out what this r is. So you can either do the long math, so we could subtract 1 for both sides, or you could just see that it's going to be a decrease by 16%, choice 4. But if you wanted to do the math on that, you weren't sure, 0.84 minus 1 is equal to minus 0.16. which is equal to negative r, and then you divide by the negative 1, and then you get r is equal to 0.16 or 16%, which is choice 4. Question number 4. Which function represents exponential decay? So this choice 1 is a little tricky because notice it's raised to the negative x. So that means we can flip this 4 because exponential decay means we're looking for a number between 0 and 1, right? So this 0.25 you might think is the answer because it's negative. This is really 4 to the x. So we flip the numerator and denominator to get the positive exponent of x. Now if we look here, what is 1.8? What is 1.8 in fraction form? It's 9/5. So this is really 9/5 to the negative x. So this too can be flipped because it has that negative. So we can flip the numerator and denominator, and we're going to get 5/9 to the x, which is a decimal between 0 and 1. So we know that choice 2 is exponential decay. Question number 5. So we have this expression, and we want to know what it's equivalent to. So because we have the denominator written in this form, x plus 2, we can use synthetic division here. So I'm just going to rewrite all the coefficients up here. We have 1, and then notice this is to the 4th degree, and there's nothing to the 3rd degree. So since there's nothing there, we're going to put a 0. And then we can go back in order. What do we have for x squared? We have the coefficient of -5, and then we have 4 and 14. And then we're going to put the opposite of this value here. So we have a positive 2, so we're going to put a negative 2. Bring down the 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is 4. So now let's write our answer. Going down in order, we had something to the 4th power, so now we're going to start with something to the 3rd power and just go down in order. And then we have this remainder here. So we're going to have 2 over what we were dividing by originally. So we get x cubed minus 2x squared minus x plus 6 plus 2 over x plus 2, which is choice 1. Question number 6. The sum of the first 20 terms of the series -2 plus 6 minus 18 plus 54, and the pattern goes on, is what? So we want the sum of the first 20 terms of this series. So if we look at the pattern of this series, we have the numbers -2, 6, and the pattern goes on. So we need to ask ourselves, what are we doing to each term? And it looks like we're multiplying times -3. -2 times -3 is 6. 6 times -3 is -18. And the same thing for -18 to get 54. So if we know this is a geometric series, and we want to know the value of the first 20 terms, we can use the geometric series formula. So that looks something like this, where the common ratio is -3. A sub 1 is the first term, is just -2. And then n is the number of terms we're trying to find, which we're trying to sum together, which is 20. And then we could just plug this in. So our first term is -2. 1 minus the common ratio, -3 raised to the n, which is 20, all over 1 minus -3. So let's plug this in. Let's start with the exponent here. We have -3 at 20, 1 minus this number we just got, times -2. and then divided by 1 minus -3 will just give us 1 plus 3, which is 4. And you'll see that we get this number, this really long number, that matches choice 3. Question number 7. If f of x is equal to this function here, then f of 1/2 is what? So let's plug this into our calculator. 2x to the 4th power minus x cubed minus 16x plus 8. And then if we go to plug in what 1/2 is equal to, if we go to second calc value and then enter 0.5 for x, you'll see that y is equal to 0. So f of 1/2 is equal to 0. So that means we know that 1/2 is an x value. So based on the factor theorem, that means that 2x minus 1 is a factor of f of x. Because if we set 2x minus 1 equal to 0, we can see that x is equal to 1/2. So that, and this is based on the factor theorem. So if you're a little fuzzy on the factor theorem, be sure to look into that. Question number 8. If 6 minus ki squared is equal to 27 minus 36i, the value of k is what? So let's expand 6 minus ki. And we get 36 minus 12ki, and then this I squared is going to become a -1. So we're going to get minus k. And we're saying it's equal to 27 minus 36i. So if we just look at 12ki, we know that, so there's no other terms that match with an I on either side of the equal sign. So if we just focus on 12ki and set it equal to 36i, we're going to be able to find what k is. So let's divide out the 12i, and you'll get k is equal to 3. Question number 9. What is the solution set of the equation x plus 2 over x plus x over 3 and set equal to 2x squared plus 6 over 3x? So I'm just going to write this over here. So we want all these to have the same denominator. So to do that, we're going to use 3x as the common denominator and just multiply the numerator by what's missing from each denominator. So here we have a 3 that's missing. So we're going to multiply the top and bottom by 3 to get 3x plus 6. And then over here, we're going to multiply the numerator and denominator by x, since x is missing from the denominator. So we're going to get plus x squared, and then we're going to set it equal to 2x squared plus 6. And I'm not writing the denominator down here, since now they all have the same denominator, we could just get rid of it. So now let's combine like terms and get everything onto one side. So we can subtract x squared from 2x squared, which will just give us x squared. And then notice we have these 6's, which will just cancel out. And then we can subtract 3x squared, 3x. So now we have x squared minus 3x, and we can take out a GCF here. We can take out a GCF here of x, and we're left with x minus 3. So if we set this equal to 0, you'll get x equals 0 and x equals 3. But be careful, because when we look back, since we were dealing with fractions, if we have a 0 in the denominator, this is going to be an error. So because this is an x equals 0, we're going to reject this. Because if we use that here as x equals 0, this wouldn't work out. So we just have this one answer, x equals 3, choice 3. Question number 10. How many real solutions exist for the systems of equations below? So this we can just plug into our calculator here. So I already have them plugged in. We have 0.25x minus 8 for y1, and then we have 1/2 x squared, or 0.5x squared plus 2x for y2. So when we graph it, it looks something like this. And notice they never intersect with each other, so that means there's 0 solutions. So the answer here is choice 4. Question number 11. Which equation represents a polynomial identity? So the first one is just not a polynomial identity. So let's try the second one. So I'm just going to write out the second part here on the right side of the equal sign, and then make sure that it matches the left side of the equal sign. So we're just going to distribute x times x squared is x cubed, x times minus xy, and then we'll just do the same thing for y, distributing y. So notice we have minus x squared y, and then we have a positive x squared y, so that means these are going to cancel out. Next we have xy squared and a minus xy squared, so these are also going to cancel out. And all we're left with is x cubed plus y cubed, which checks out with the left side of the equation. So choice 2 is our polynomial identity. And if you tested out these other two answer choices, this wouldn't work out. Question number 12. The expression x to the 1/5 over x to the 1/2 can be rewritten as, so whenever we have exponents like this, we can subtract these. So we can say 1/5, x to the 1/5 minus 1/2, and see what that comes out to. We get -3/10. So if we wanted to write this in fraction form, it would look something like this. So since that's negative, we can make it positive by doing this, putting a 1 over it. And if you look at what formats they're putting it in, they're using radicals. So if we want to put it in radical form, it would just be something like this. 1 over the 10th root of x cubed. And those are just rational exponent rules. This is just based on exponent rules. So the choice we're looking for is choice 3 as our answer. Question 13. A cyclist pedals a bike at a rate of 60 revolutions per minute. The height h of a pedal at time t in seconds is plotted below. So if you look at this, it kind of looks like a sine function. The graph can be modeled by the function h of t is equal to 5 sine of kt, where k is equal to what? So let's dissect this a little bit. H of t is equal to 5 sine of kt. So if we're looking at k is our frequency. And this represents the number of s cycles between 0 and pi. And we're dealing with s cycles because we're dealing with sine. And 2 pi. So even though we're trying to find k, we can't forget about t, because we're going to need to know what t is in order to answer this question. So t is our period, and this is the length of one cycle. So the period has a formula where we know that t is always equal to 2 pi over the absolute value of the frequency. But we don't know what the frequency is, because we don't know where 2 pi is on here, but we can see that one cycle, the length of one cycle is equal to 1, because if you look at this is one cycle of sine and it ends at 1, right? One cycle of sine just looks like that. So it ends here at 1. So if we know the length of one cycle, the period is equal to 1, that means we can find this missing frequency. So just by using this formula. So if we know the absolute value of the frequency is equal to 1, and the frequency is going to be represented by k, so I'm just going to put a k in there. Then we could say that k, because k times 1 is just going to be k, is equal to 2 pi. And that's choice number 2. Question number 14. Which statement about data collection is most accurate? Choice number 1. So let's just go through each and see what makes sense. Choice number 1. A survey about parenting styles given to every 10th student entering the library will provide unbiased results. So this is strange to be asking students about parenting styles, assuming none of them are parents yet. So we're just going to say no. An observational study allows a researcher to determine the cause of an outcome. So that's not true. Margin of error increases as sample size increases. Also not true, because if sample size is increasing, that actually means we have more data and the margin of error will be getting smaller. And choice number 4, a survey collected from a random sample of students in a school can be used to represent the opinions of the school population. So yeah, that makes the most sense. So we're randomly sampling students in a school, and then this will represent the opinions of people going to school there. So yeah, choice 4 is our answer. Question 15. If f of x is equal to 1/2 x plus 2, then the inverse function is what? So I'm going to write down the function over here. And now we're going to switch the places of the x and y. So here was y, and now x is going to go here. And now here is x, and now we're going to put y. And now we're going to solve for y. So we get x minus 2 is equal to 1/2 y. Multiply 2 on both sides, and we get 2x minus 4 is equal to y. The inverse function is equal to 2x minus 4, which is choice number 3. Question 16. If f of x is equal to x to the 4th power minus x cubed minus 6x squared, what values will y be positive? So let's look at what this is going to look like on our calculator. So we're wondering where y is positive. So we could see that y is positive over going this way, less than this value, and greater than this value. We just want to look at what values those are. So we could look and see that this is -2 on the left, and here's 0. That's also another 0 value. And then this over here is 3. So we know that y is positive when x is less than -2, or when x is greater than 3. So that is choice number 2. Question 17. For which values of x will log of x plus 5 equal to the absolute value of x minus 1 minus 3? So we're finding the x values for this, but notice it has a log and it has an absolute value. So the important thing here is really the absolute value. Because of that, there's going to be 2 options. So this is going to be, so because of this absolute value, we're going to have 2 options to plug into our calculator, 2 potential equations. So we have log of x plus 5, which is just keeping that the same. And then this x minus 1, we can just leave it as it is, x minus 1 minus 3. And then we can just calculate like terms. -1 minus 3 is x minus 4. And then if we move everything to one side, so we're going to move x minus 4 over, we'll just get log of x plus 5 minus x plus 4 is equal to 0, or equal to y. So let's plug that into our calculator. So you'll see that the graph of it looks something like this. And then we go to second calc, where y is equal to 0. We get x is equal to 5. So we have that in the answer choices, so we know we're going in the right direction. We can eliminate choice number 2. And now, so this was if we kept the absolute value the same. So now let's do the same thing. This time, changing the sign of this. So what if this was a negative x? And this was a positive 1 because we have the absolute value of it. So we don't know. It could be either 1. And then minus 3, just bringing down that 3. So now we're just going to bring it over so we can plug it into our calculator. So we get log of x plus 5 plus x plus 2 equal to 0. So now we just have to adjust what we have plugged in here. So we have log of x plus 5, and now instead of minus x, we have plus x, and then plus 2. So we'll look at what that graph looks like, and then find the x value right here. And we get x is equal to negative 2.41, about. So we know that the answer choice is choice 3. Question 18. Consider a cubic polynomial with the following characteristics below. So exactly 1 real root, and as x approaches infinity, f of x is going to be negative infinity. So we know we have a cubic polynomial dealing with x cubed, but we know that as x approaches infinity, so we're going this way, y is going to be going down. So it's going to look something like this. Okay, so this is not your typical x cubed, this is going to be like a negative x cubed function. So something to keep in mind, if you don't know that, that's okay. We're also going to be plugging in numbers and seeing what makes sense. So given a is greater than 0 and b is greater than 0, which equation represents a cubic polynomial with these characteristics? So I'm going to be plugging in numbers. Let's put in 2 for a and b for 3. So I'm just going to rewrite each function with the parameters and see which one lines up with both of them. So this is going to take a little bit. So we rewrote our functions, and now I'm just going to write down the parameters they're looking for. Okay, now we're set up to check this question by going through each answer choice. So let's first put in this first function here, x minus 2 times x squared plus 3. So notice we have a picture like this, where we have 1 real root, but notice as x is approaching infinity, y is increasing, not decreasing. So no. Choice number 2. Let's plug that into our calculator and see what happens. So this looks right. We have exactly 1 real root, and as x is approaching infinity, f of x is approaching negative infinity. So choice 2 is our answer. And if you were to go through and check the rest of these, it would not work out. Question 19. Betty conducted a survey of her class to see if they like pizza. She gathered 200 responses, and 65% of the voters said that they did like pizza. Betty then ran a simulation of 400 more surveys, each with 200 responses, assuming that 65% of the voters would like pizza. The output of the simulation is shown below. Considering the middle 95% of the data, what is the margin of error for the simulation? So the margin of error is just going to be, in this case, since we're dealing with the middle 95%, is just going to be 2 times sigma. So whenever we have the middle 95% and we're dealing with the margin of error, we're just going to do 2 times the sigma or the standard deviation, which in this case they give us right here is 0.035. So we just gotta plug that into our calculator and we get 0.07. So this was very wordy kind of a problem explaining the data we're looking at, but the answer is actually really easy to get, so don't get intimidated by all these words. Question 20. If cosine of A is equal to radical 5 over 3 and tan of A is less than 0, what is the value of sine of A? So right away I think of this trig identity. Cosine squared of A plus sine squared of A is equal to 1. So cosine of A, we already know, is radical 5 over 3. And we're saying squared plus sine of A squared, which we don't know what it is yet, is equal to 1. So we could just solve this algebraically. So now to get the value of A, we're just going to take the square root of both sides. And since it's the square root, we're going to do plus or minus. So plus or minus radical 4 over 9 will give us plus or minus radical 2/3. There's only one answer choice here. And if you look back, it says tan of A is going to be less than 0. So we have two potential answers here, and we need tan of A. So if you think about the quadrants, we need to think about where tan is less than 0. So it can be either here or here. So let's look at what the potential value of sine of A is. So we have, plus or minus 2/3. We already took the radical of it, sorry. So plus or minus 2/3. So if we do sine of 2/3, let's see what degree this is. Second sine 2 divided by 3, so that's our arc sine, we get 41.81 degrees. So 41.81 degrees would fall into this first quadrant here, so we know that 2/3 is not the answer because tan would be positive in here. So let's try arc sine of negative 2/3. And we get negative 41.81 degrees. So this 270 is also negative 90 degrees. So that means the angle would fall in here, in the fourth quadrant, where cosine is positive and where tan is negative. So we know that negative 2/3 is our answer, choice 3. Question 21. A tree farm initially has 158 trees. Each year, 20% of the trees are cut down and 80 seedlings are planted. Which recursive formula models the number of trees a sub n after n years? So we have initial a sub 1 is 150. So right away you could see answers 3 and 4 aren't even in recursive formula notation, so those are not the answer. And then next, these look very similar. Let's look at this. Each year 20% of the trees are cut down. So 20% of the trees. So even though we're dealing with 20, we're really actually keeping 80% of the trees. We're getting rid of 20% of them. So we're going to have 80% of the trees cut down plus 80 seedlings are planted. So the answer here is going to be choice 2. Question number 22. Which equation represents a parabola with a focus of 4, -3, and directrix of y equals 1? So let's draw out what this looks like. So we have the focus, and then the directrix is y equals 1. And we know that the parabola, the vertex of the parabola, is going to be equidistant between these 2 points. So this point, so this whole thing is y equals 1. But this particular point here, where it has to be equidistant, the vertex is point, you could see 4, 1. So we want to find the vertex. So to get the vertex, so we need to find the midpoint between the directrix and the focus to find the vertex. So we're just going to use the midpoint formula. So we're going to take these 2 points, 4, 1 from the directrix, and then the focus, 4, -3, and then just find the midpoint, which will be our vertex. So we have, and we're just finding the average between the two. So we have averaging the x values, x plus x is 4 plus 4 divided by 2, and then y plus y is -3 plus 1 divided by 2. So then we could see that our vertex is going to be equal to 4, -1. And now we just need to look for a vertex in the answer choices that has 4, -1, which is choice 4. Question 23. Mia has a student loan that is in deferment, meaning that she does not need to make payments right now. The balance of her loan account during her deferment can be represented by the function f of x is equal to 35,000 times 1.0325 raised to the x, where x is the number of years since the deferment began. If the bank decides to calculate her balance showing a monthly growth rate, an approximately equivalent function would be what? So the thing that we want to do here is adjust the rate and adjust the exponent proportionally so that our formula doesn't change, but now we can involve months. So if we look at, so we want to be adjusting this number and this number outside the front. So we have, so we're going to keep the 35,000 is going to stay the same. And where's our original function? So here's our original function, 1.0325. So we want to know what it is on a monthly basis. So 1 out of 12 months in a year. But remember, we don't want to adjust our rate without adjusting the number of years since the deferment began, the exponent value. So we're going to have 12x outside. So if these would kind of cancel each other out, not affecting the entire formula. So now what we're going to do is just calculate this inside the parentheses. So 1.0325 raised to the 1 divided by 12. When we do that, we get 1.0027 about and raised to the 12x, which is choice number 1. Question 24. Which graph shows a quadratic function with 2 imaginary zeros? So right away we could cancel out choice number 4. This isn't even a function. Choice number 3 is not a quadratic function, it's a quartic function, meaning it has exponent value raised to the 4th power. And notice here, I kind of went backwards. Choice number 1 has 1 real root right here, so that's not our answer. By process of elimination, we know that the answer is choice 2, which has a parabola and has an imaginary root. So choice 2 is our answer. So this is the end of part 1. I hope you found this helpful. Look out for part 2 coming out soon. Thanks so much for stopping by and happy calculating. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!